Okay, so we're starting with the basics. Okay, so finding X-intercepts, finding Y-intercepts. If we want to find X and Y-intercepts, we can algebraically either.
Good morning again, Milton Eagles. For all staff, students, and teachers, we are now under a soft lockdown.
We're doing all of them. We're doing all of them.
Thank you.
Okay, so X-intercepts, we can set Y equal to 0 and solve for X. For Y-intercepts, we can set X equal to 0 and solve for Y. So for instance, if I had a graph that looked like this here, okay, I want to find the X-intercepts. These are the X-intercepts here. I can simply replace the Y with 0 and then either solve for X. If it's not factorable, then we would just go ahead and use our calculators and find those X-intercepts. Okay. To find Y-intercept, we would set X equal to 0 and then solve for Y. So if I want to find X-intercepts, yeah, in this case, I think I had a duplicate here. But if I want to find the Y-intercept, I would just replace the X with 0 and solve for Y. So for instance, if my function was x cubed plus 2x squared plus 1, to find the Y-intercept, replace the X with 0, and then I can solve for Y. So in this case, okay, so order pair will be at 0, 1. Okay. Okay, just basics there. Let's talk about symmetry. We can find there are different symmetries involved that we want to make sure that we know. There's y-axis symmetry, there's x-axis symmetry, and there's also origin symmetry. So to get, you can imagine y-axis symmetry. If you can fold the graph over the y-axis and you can see the graph kind of overlapping each other, right? So that's y-axis symmetry. So for instance, let's try this one here. So y-axis symmetry. An easy one that that we all kind of recognize is y equals x squared. We know what the graph looks like, just a parabola through the origin. Okay, visually, we can convince ourselves that there is y-axis symmetry. Let's see, zoom in a bit more here. Okay, but algebraically, we can replace the x's with negative x and see if the equation will remain unchanged, and it should, because we have that x being squared, right? So we're going to replace the x with negative x. And the result of that is y is equal to parentheses negative x quantity squared. And we can see that going back to our starting point, right? And so therefore, we can expect there to be y-axis symmetry. Okay, second example, x-axis symmetry. So x-axis symmetry, that means visually you can fold the graph over the x-axis and you get a perfect overlap. Right? So I can replace the y with negative y and see if the equation remained unchanged. So an easy example for x-axis symmetry would be x equals y squared. So if I have x equals y squared, you can imagine folding the graph over the x-axis.
This concludes our soft lockdown. We will now proceed into the hard lockdown. Please follow all protocol. Thank you.
Okay, next up we have x-axis symmetry. So this is where we can replace the y's with negative y and see if the equation remain unchanged. And we expect that to happen because the y is nicely squared. So any replacement of a negative y will go right back to the original starting equation. Okay, so we'll make that substitution. So it cleans up nicely. X equals y squared. We're back to our starting equation, no changes. So therefore, x-axis symmetry. Okay, so we see it from an algebraic perspective. We also see it from a visual perspective.
Is this supposed to be on like the?
Oh,
I'm a little confused.
I'm just going through some examples.
Oh, okay.
Yeah, and then we're gonna see them show up here as well. But right now, I just want to kind of just give you a visual representation, and we'll look at some examples. Yep. Next one here is origin symmetry. Okay, so origin symmetry, you can imagine if I can flip the graph upside down, and if the graph still remains the same, then I know I have origin symmetry. Okay, so I just want to give an example, quick example of that. So origin symmetry. Example of this could be y equals x cubed. And with origin symmetry, our rule is we're going to be replacing both the x and y with negative x and negative y. And then after everything is cleaned up, will it bring us back to our original form? If it does, then algebraically we know that there's going to be origin symmetry. Okay. So go ahead and do that. Replace the x and y. Every variable with a negative version of itself. And let's see what happens there. Okay, if I clean this up, will this bring me back to my original starting point? Let's see. So negative y will stay negative y. Negative x cubed will just, right, this is raised to an odd power, so that negative is not going to go away. It'll still remain with the problem. And now, it's not quite the same, but what if I multiply both sides with -1 or divide both sides by -1? Let's see. -1 times -y becomes y. -1 times -x cubed becomes x cubed. So we did come back to our original starting point. It passes the test. We have origin symmetry for this graph. Okay, so I want to kind of go through that there are actually two more options here. It's also possible that we get no symmetry, where it doesn't pass any of the symmetry tests. You know, like a polynomial. All right, doesn't matter if you flip it upside down or if you fold it over the x or y axis. we're not getting any of the symmetries to occur, so that's possible. And we're going to see an example of this later on, that you could have multiple symmetries. Okay, so where it passes more than one test. Okay, so so now let's go back to the worksheet here. Oh, there's a follow-up question here. Can graphs with x-axis symmetry be functions? We see x-axis symmetry. It's not going to pass a vertical line test, right? So. Okay, so to describe the symmetry of the following, we've done this already, x squared. Any negative x that replaces that will just go back to the original starting point. So we expect that to be y-axis symmetry. Y equals x cubed. We just saw this, where if I replace both the x and y with negative, I'm able to get that test to pass origin symmetry. Okay, now third one here, y equals x squared minus x. Let's go down the options to see if it will fulfill any of the conditions. An easy one for me to test here is replacing y with negative y, see if it will pass the x-axis symmetry. Well, if I replace y with negative y, that's just going to change signs, and that's obviously just not going to be the same equation as my starting one, right? So I know that one is out. If I try to go for y-axis symmetry, replace the x's with negative x, this is okay, right? We know that this will go back to a starting point, but this negative x will turn into a positive x, and that's automatically just not going to pass the test, right? Okay, what about the third one? What about origin symmetry? Okay, so origin symmetry, I'm going to replace the x's and the y's with negative y and negative x's, and let's just see what happens there. So I'm going to take every variable, replace it with the negative version of itself, and then we're just going to work our way through and see if we can convince ourselves whether we're back to our starting point or whether we have something different. If we have the exact same as our starting point, we know it's going to pass, it's going to be an origin symmetry. But if it's even slightly different after we clean it up, then we just have to say that it doesn't pass that test and therefore doesn't have origin symmetry. Okay, let's clean this up, see what happens. Negative y will stay negative y. The negative x squared, we know that will go back to positive. This negative x doesn't go away, but it will cancel out with this negative, so 2 negatives becomes positive. So it doesn't look like the same thing, right? And if I go a little bit further by multiplying everything through by -1, I should be able to further convince myself that I am not staring at the same equation. Right, not the same thing, right? So no symmetry, right? Doesn't pass the x, doesn't pass the y, doesn't pass the origin symmetry. Okay, x squared plus y squared equals 25. Anybody know what that graph looks like? Okay, maybe if I put in standard form, it'll be easier to recognize. Okay, any idea? What shape is that? Okay, this is going to be a circle. Okay, there's a center at 0, 0. There's a radius of 5. Okay, I just want to kind of do a visual perspective first, and then we'll do the algebraic perspective. So without doing the algebra, let's just look at it from a visual perspective here. What type of symmetry could we expect out of this? Okay, so will it pass the y-axis symmetry, you think? Right. We should be able to take this graph and fold it over the y-axis and get that perfect overlap, right? How about x-axis symmetry? Yeah. Yes, you can fold it over the x-axis. You can get that to, you can visualize that. What about the origin? What about origin symmetry? Yeah, you flip it upside down, it's still the same circle, right? Nothing's changed. So we know it's going to pass all 3 symmetries, but from an algebra perspective, can we convince ourselves of that as well? Well, if I replace y with negative y, that will come back to the starting point. That's squared. If I replace x with negative x, that will bring me back to my starting point. If I replace both the x and the y with negative x, negative y, both will go back to my starting point, right? So algebraically, it makes sense. Visually, it makes sense. So we have all 3 symmetries represented here. Okay. Next page. All right, if there's one thing that I want to say is the most important thing from this chapter P, from this pre-calculus unit, it's just being able to solve equations algebraically. It's going to kind of sound strange, but typically when we get into calculus, students typically don't. Students do make mistakes with calculus, but typically, I guess the surprising thing is that most of the mistakes that are made it's going to be on the algebra side of things, on the cleaning up side of things, and on the back end of the problem. And we're just going to kind of spend some time to kind of make sure that we are understanding our algebraic basics, our foundations, and just things like that. Many of these things you already know, but you just kind of need to have some time to kind of refresh your memory. So, okay, so let's look at this example here, or this type of problem. To find points of intersection, we're going to solve an equation for one variable and then substitute into the other equation. Okay. So let's find the points of intersection for the following. X squared plus y squared equals 25. We know what that shape is. That's a circle. 2x plus y equals 10. What is that going to be? That's just a what? Is that a curve? Is that just a line? Yep, just a line. So before we jump into the algebra side of things, what are the possible ways that a circle and a line can interact with each other? How many solutions could we potentially have? Okay, you have 2, right? You can imagine. So 2 is a possibility if the line crosses the circle at 2 points, but it could also be what? It could be one solution if it's tangent to the circle. Is there another possibility? 0, right? It's possible that the line doesn't even touch the circle, right? Okay, now we could graph these equations and find a solution that way, but we're going to do it from an algebraic perspective. Okay. So we're going to solve for one variable so that we can substitute into the other equation right now we have too many variables going on. We want to get it down to one variable. So which variable do you think will be the easiest one to target from these two equations? Yeah, the y, right? I mean, we could solve for x, but then you got to deal with the fraction. You got to divide the 2 out. So why mess with the fraction if we have an easier path to work from? So we're going to target this y here. I'm going to solve for that variable. Okay. Solve for y. Now, I'm going to insert this into my other equation. Okay, I have a nice clean path because I have y is equal to 10 minus 2x. This will insert nicely into my y variable. And now I can get one equation down to one variable, and I can just focus my attention on just that one variable. Okay, from here, we're going to go down and we're going to try to solve for x. Okay. I want to point out a couple of missteps, and then I'll list out the steps, and then I'm going to have you guys see how far you can get on your own, and we'll walk around and just be able to help you out if you're stuck or you just want to kind of see where you are with this, because this is we're going to see this a lot. We're going to see this a lot over the course of calculus. It's just having to do certain cleanups require us to, understand the steps of foiling and combining like terms and factoring and solving. Okay. One thing I want to point out is that we got to be careful with binomial squared, right? You can't just distribute the exponent through and then be done. That's part of it, but it's not the whole thing. Okay, so I want to make sure that we don't do this. If I see a binomial squared, okay, it's not the same thing as just distributing that exponent through. That minus makes everything a little bit messier. Okay, we can't do that. If you see a binomial squared, my suggestion is write it out twice. That way, you can convince yourself that, okay, there's more going on than what I'm expecting here. So I got to distribute, combine like terms. Okay. So I want to make sure you guys understand that step. Okay. So after this step, okay, let me kind of highlight the steps that we're going to take here. Okay. So we're going to expand. Okay, you're going to combine like terms. Okay, make sure that you set equal to 0. Because if you are trying to factor and then the right side has a different number than 0, then we're not going to get the right answer. So you got to make sure you bring everything over to one side first, clean everything up first before you go through that factoring step. Okay, take the steps that you need to factor, and then solve, and then finally you're going to find your order pairs. All right, let's see how you guys do.
Good afternoon, Milton Eagles. Students, if you have lunch/study hall course period, please proceed to your study hall class when the bell rings at 11:30. 9th and 10th graders will have lunch A. 11th and 12th graders will have lunch B. Teachers, if you have any more students who have bus information questions, please give that to them at that time in the study hall. Students, if you have not been issued a Fulton County device and would like to have one issued, please report to the media center during your study hall. We will be registering juniors for the junior parking lottery during lunches in the cafeteria, Monday through Thursday. We will announce the winners on Friday. You will need a valid driver's license and know your student ID number to register. Also, locker assignments will be given out in the cafeteria. Thank you.
Guys, I forgot that our time was severely shortened today, so we'll pick this up tomorrow, and we'll just continue our time through this. Got a suggestion here is, I'm not going to check the first set of homework P1 to P3 until next Monday, but if you guys can kind of chip away at it, so you're not waiting until Sunday to do all this work, just do a little bit each day, and that way you'll get it, P1 to P3 done by this weekend. Yeah, guys. We'll finish this tomorrow. Okay, we'll finish this tomorrow. So I definitely we're definitely gonna need to spend some time with this. Make sure everybody's good with this.
Wait, can you repeat that all again?
Oh, the first set of homework is going to be due next Monday, P1 through P3. But if you guys can chip away at it and just do a little bit each day, you're not waiting until Sunday to do it all. Have a great day, guys. Thank you. Bye. Thank you.